Good evening, students.
Good
So, redox reaction, right?
Yes, sir.
Today we will complete almost all the redox reactions. So, what is oxidizing agent? What is reducing agent? What is the difference between the oxidizing agent and reducing agent?
Sir, oxidization agent helps in oxidation, like addition of oxygen, sir. But it gets reduced, sir. While reducing agent gets oxidized, but helps in reduction.
Okay. What is the meaning of redox?
Both the reduction and oxidation happens in the same reaction, sir.
Okay. So that day I talk about the oxidation state of how to arrive the oxidation state of a metal or atom, isn't it?
Yes, sir.
This is what we have discussed, right? Previously. Have we find out this? We find out what is the oxidation state of calcium, copper. You tell me what is the oxidation state of calcium? What is the oxidation state of copper? Copper and copper oxide, copper and copper nitrate. Tell me what is the oxidation state of calcium?
Sir, it's 2, sir. Plus 2, sir.
For what about copper oxide?
-6, sir.
How much? How much for the copper oxide? First one, this one.
-2, sir.
This one. This is +2. What about this?
-2, sir, for copper.
For copper nitrate?
So is it 5, sir?
NO3 become -1. So +2. This become +2. All are +2 only. So oxidation, you can give number of way. So what are the oxidation definition? It is a process in which electrons are lost from an atom or ion. So oxidation is a process which involves addition of oxygen. So oxidation is a process which involves removal of hydrogen. Addition of any electronegative element is called oxidation. Removal of any electropositive element is called as oxidation. So I'm going to differentiate oxidation versus reduction. Electrons are lost from an atom or ion. So what is the reduction? It is a process in which an atom or ion gains one or more electrons. So addition of oxygen. It will be removal of oxygen. And then removal of hydrogen. Here it will be addition of hydrogen. Next, addition of electronegative elements. Appo, what is the subsequent to this one? Removal of any electronegative elements. Removal of any electro positive elements. Addition of electro positive elements. Okay, by this way we can classify oxidation reduction. So we know that what is the oxidation. Now we have to see what is oxidizing and reducing agents. So a substance which can gain electrons, that is undergoing reduction, is known as oxidizing agent, or otherwise oxidant. Okay, a substance which can lose electrons, otherwise that is undergoing oxidation, is known as reducing agent or reductant. Okay, so we can classify oxidizing and reducing. So some of the substance which can possess both the property. So Based on the condition, it will behave as an oxidizing agent and then reducing agent. So we'll see what are the examples. So example for oxidizing agent. Will be KMnO4, K2Cr2O7, chromic acid, sulfuric acid, nitric acid, sulfur trioxide, FeCl, the ferric chloride, oxygen, ozone, P2O5 or otherwise P4O10, sodium nitrate. These are the things which will behave as the oxidizing agent. And then reducing agent. Example, ferrous sulfate, tin chloride, ferrous chloride, H2S, HI, HBr, HCl, lithium, sodium, cesium, aluminium, iron, zinc, mercurous chloride, copper oxide, sodium hydrate, sodium borohydrate, lithium borohydrate, lithium aluminum hydrate, all are reducing agents. Then both reducing and oxidizing agent. So it will be H2 hydrogen peroxide, H2O2, SO2, H2SO3, HNO2, NaNO2, Na2SO3. These are behave as both the reducing as well as oxidizing agent. Okay, now we are going to see types of redox reaction that we have to see. Okay, and then equivalent weight. So the equivalent weight also, which is very important factor for the oxidizing and reducing agent. How to get the equivalent weight? So the equivalent weight is what we can say. So the molecular weight divided by number of electron get transferred or transferred, or otherwise electron gained or lost in the balanced chemical equation. We are saying that equivalent weight. Equivalent weight means when you are when the reaction is going, means how much amount is required to complete the reaction stoichiometrically. That is known as equivalent. For example, when you are taking potassium permanganate molecular weight is around 155, but the equivalent weight is vary with the medium. In the acid medium one rate, one equivalent weight, in basic medium one equivalent weight, and neutral medium one equivalent weight, because the electron get transferred will be different. Okay, so how to calculate the equivalent weight of oxidizing and reducing agent become? So it can be divided the molecular weight, whatever the molecular weight, that divided by how many electrons get transferred, that is known as equivalent weight. So molecular weight divided by number of electrons. Electrons gained or lost. This is for equal weight of oxidant or reductant, or otherwise equivalent weight of oxidant reductant. It could be formula weight divided by total change in oxidation number. Okay, so by this way we can change it. And then next one, types of redox reaction. So we have to see the redox reaction. What are the redox reactions? So generally organic reaction, we can say substitution, addition, we are saying no. Likewise, we can classify the redox reaction by the combination reaction, decomposition reaction, displacement reaction, dispropanation reaction. These are the way by which you can classify the redox reaction. Okay, types of redox reaction. And then we have to see the balancing of redox reaction. So, and then we have to see the what is redox reaction and the electron process we have to see. So that's all about the unit. We'll see. So types of redox reaction. Number one, combination reaction. Number two, decomposition reaction. Number three, displacement reaction. Then number four, dispropanation. Dispropanation. First, what is combination reaction? So these are the reaction in which two atoms or molecule to combine together to form the third molecule. In this reaction, at least one of the reactant must be in the elemental form. Okay. For example, when you have the carbon plus two hydrogen gas, when you are combining, it will form CH4. So this is a redox reaction. So you check that oxidation number of carbon, it has been changed. Oxidation state of hydrogen, it has been changed. So this is known as redox reaction. So what is the condition in this reaction? The one of the reactant must be in the elemental form. And then we are going to see about the decomposition reaction. So these are the reaction in which a molecule or a compound break down to form. So here combine. The atoms should combine together to form the third molecule. And here decomposition, breakdown. Breakdown to form two or more number of molecules. So these are reverse of combination reaction. It will be a reverse of combination reaction. For this reaction, the redox reaction, one of the product must be elemental. Here, one of the reactant elemental form should be elemental. Here, one of the product should be elemental form. For example, two KClO3, it gives 2 KCl plus 3 O2. So product should be in the elemental form. And then displacement reaction. So the displacement reaction in which atom or ion in a compound replaced by another atom or ion are called displacement. Simply we can write that equation AB plus C, it gives AC plus B. It's a displacement. So it will be two types. What are the two types? One will be metal displacement, non-metal displacement. So one will be metal based, another one will be non-metal based. So in the metal based, if a metal atom or ion is displaced by another metal or atom ion is called metal displacement reaction. Example, TiCl4 plus 2 magnesium, it gives Ti plus 2 MgCl2. The non-metal, zinc plus sulfuric acid, it gives zinc sulfate plus hydrogen evolution, the non-metal displacement. And then dispropionation reaction. These are the reaction in which single species is oxidized as well as reduced simultaneously. Then the reaction is called as dispropionation reaction. So the dispropionation reactions are the reaction with single species is oxidized as well as reduced simultaneously. So in this reaction, the reacting species must have element can have at least 3 variable oxidation on the elements on the it can go. So for example, 3ClO2 minus, when it dispose propionate, it will give Cl minus plus 2ClO3 minus. So when you are checking the oxidation state, the chlorine will be plus 3 for here. Here chlorine oxidation is plus 3. When coming here, it will become minus 1. Here when you are coming here, it will become plus 5. So different oxidation state. That's why it will become different. So are able to understand more the types of redox reaction? So combination, decomposition, displacement, and dispropionation. Combination reaction, one of the reactants should be in the elemental form. Decomposition is reverse of combination. One of the products should be in the elemental form. Displacement, it will be metal displacement or non-metal displacement. If one of the metal displaced by the other metal, it will be metal displaced. One of the metal is displaced, the other one means it is a non-metal displacement. And then dispropionation reaction, the single species is undergo oxidation as well as reduction simultaneously, then it is called dispropionation reaction. So here the species should have the 3 different variable oxidation states, then only it will undergo. Now the important thing, balancing of redox reaction. So we are going to discuss about balancing of redox reaction. So how to balance the redox reaction? We know that the general equation given, so we have to balance the equation. How will you balance? So there are 2 methods available to balance the redox reaction. One is oxidation number method, another one is off reaction method. We'll see one by one. First one, oxidation number method. Oxidation number method. Another one is off reaction method. So oxidation number method, this method involves following points. So what are the points? Step 1. First we have to write the skeleton redox reaction. And then so we have to identify the elements undergoing oxidation or reduction. And the write the oxidation number of atom of the above symbols. And then, so first we have to identify the element which undergo oxidation and reduction and write the oxidation number of atom above the symbol. And then third step, we have to balance, increase in oxidation number and decrease in oxidation number by multiplying the oxidant and reductant with the suitable integer. The final fourth step, last but one step. So we have to balance the atoms other than hydrogen and oxygen. Finally, only we have to adjust the hydrogen and oxygen. And the final step, so balance hydrogen and oxygen. So here also in acidic medium, add H2O to balance oxygen and add H plus ion to balance hydrogen atoms. In case in basic medium, what to do? Add OH minus ion to balance charge. Add water to balance hydrogen and oxygen atoms to the other side. So whatever side you are adding OH, the opposite side. For suppose if you are adding OH on the reduction side, I mean reactant side, then you have to add the water on the product side. So are able to understand what I am saying? So when you are adding reactant, it gives product. This is the simplest reaction. So if you are adding OH minus over the reactant side, then the H2O to the product side. Okay. So we'll see about the off reaction method. This method involves the following step. So step number 1, we have to write the equation in ionic form. And then step 2, split the reaction into 2 off. Two off reactions. So one for oxidation and other for reduction. Okay. And the step 3. So we have to balance each of reaction. So by using this rule, number 1, first we have to balance the atom which undergo oxidation or reduction, and then second, so balance atom other than hydrogen and oxygen. Same rule here also. Balance the atoms other than hydrogen and oxygen. So next, in acidic or neutral one solution, add H2O to the side deficient in oxygen, and H plus to the side deficient in hydrogen. This one way. And then in basic medium, for each excess of oxygen and water to the same side and 2H minus to the other side. So for each excess of oxygen, add H2O to the same side. And 2 OH minus ions to the other side. So look here, for each excess of oxygen, we have to add water. Okay. So it become 2 hydrogen, 2 oxygen. And the opposite side, if you are adding 2 OH minus, it will be neutralized. Okay. That's what they said. For suppose add 1 OH ion for each excess one OH minus ions for each excess of hydrogen on same side. And 1 water molecule to the other side. So first step 1, step 2, step 3. Now we are going for step 4. So we have to add electron to the side deficient in electrons to balance the charge. Step. So multiply 2 off reactions by suitable integer. So to equalize the number of electrons in both the reaction. To equalize number of electrons in both reactions. And then step 6, final step. So add 2 off reaction to achieve overall reaction and cancel the electron on each side. Now we will work it out the problems. Okay, for a reaction we will equalize in both the case, oxidation method as well as NCERT ல இருக்க கொடுத்ததை ஒன்னு எடுத்துக்கலாமா? So to balance P4 solid plus OH minus aqueous, it gives TH3 plus HPO2 minus aqueous. Is it gas? So now we have to equalize. So render method we have seen the two method, right? First we'll go by the oxidation number method. Oxidation number method. So first oxidation method write the skeleton redox reaction, identify the element undergoing oxidation reduction, and balance the increase the oxidation number or decrease the oxidation number by multiplying oxidant and reductant with suitable integer, and balance the atom other than hydrogen and oxygen. Finally, we have to balance the hydrogen and oxygen. So we'll see. So and also in basic medium, add OH to balance the charge, add H2O to balance the hydrogen oxide on the other side. இப்போ இது basic medium. இப்போ எப்படி equalize பண்ணலாம்னு பாருங்க. First, என்னது, we have to identify the skeletal reaction. This one P4 OH minus, it give PH3 and H2. H2 PO2 minus. H2 PO2 minus. So look here, in the elemental form, what is the oxidation number of the phosphorus? It will be 0. Here the phosphorus become, what is the oxidation number for the phosphorus? pH3. What is the oxidation number ma for pH3 in the phosphorus? Hydrogen become +1. So phosphorus plus 3 into 1 becomes 0. So phosphorus become -3. So -3. So oxidation number is changed. And also when you are coming here, 2 into 1 plus phosphorus, 2 into -2 become -1. So 2 plus P -4 become -1. So when it change 2 -2 become -1. P is equal to -2 plus 2. It become +1. So what is that? Total increase in the oxidation number P4 to pH3 is how much? It was increased in the three times, no? And then total increase oxidation number P4 into H2P2O4, it's 1. So we have to write, how to write? So in the oxidation number, total decrease oxidation number of P4 in pH3, 0 to -3. Correct? So what is the rule said? Balance increase in oxidation number or decrease in the oxidation number by multiplying the oxidation and reductant with suitable integer. So we have to find out, no? So total decrease in the oxidation number of P4. Totally how much is decreasing, ma? 3 into 4, it becomes 12. -3 liya, 0, -1, -2, -3. So total decrease வந்து 4 phosphorus atom. 3 decrease ஆகுது இல்லையா? 3 into 4, 12. And then total increase oxidation number of P4 in H2PO2 minus. That we have to find. So here 4 phosphorus plus 1 ஆயிருக்கு இல்லையா? அப்போ 1 into 4 it become 4. Are able to understand, ma? Decrease ஆனது பாருங்க, 4 phosphorus minus 3 ஆகிருக்கு. அப்போ 3 4s are 12. Decrease the oxidation number. Increase the oxidation number of P4 become 4. Now therefore P4 to balance increase by decrease the oxidation number. So multiplying phosphine by 1, H2PO2 by, we have to write 3. So whatever the given reaction, P4 should be OH minus 1. It gives PH3 and then 3 H2PO2 minus. So you may ask, so how you are multiply phosphorus by 1 and H2PO2 by minus by 3? என்ன பண்ணிருக்கோம்? இங்க டிக்ரீஸ் ஆனது 3 டிக்ரீஸ் ஆயிருக்கு, 4 பாஸ்பரஸ்க்கு. இன்க்ரீஸ் ஆனது 4 இன்க்ரீஸ் ஆயிருக்கு. அதனால என்ன பண்ணிருக்கோம்? சோ பாஸ்பரஸ் P4 இருக்கு இல்லையா? சோ இதுல இருந்து 4 குறைஞ்சிருக்கு இல்லையா? அதுக்கு 1. இங்க இருந்து இது பாரு 1 குறைஞ்சிருக்கு. 4 become 1. அந்த இடத்துல 3 மாத்திரும். +1லயும் இப்ப இதுல என்ன இருக்கு? -3 இருக்கு. இப்ப என்ன இருக்கும்? +3 ஆயிடும். சோ -3 + 3 become 0. அதனாலதான் இது 1ஆலயும் இது 3ஆலயும் பிரிக்குது. புரியுதா? பாஸ்பரஸை நியூட்ரலைஸ் பண்ணுமா? இங்க பாஸ்பரஸ் 0 ஆக்சிடேஷன் ஸ்டேட், இங்க வரும்போது -3, இங்க வரும்போது +1. அதனால +1 இங்கேயும் 3 இங்கேயும் எடுத்துட்டோம்னா it will be neutralized. Are able to understand? Is it clear? Is it clear?
Yes, sir.
Yes, sir.
Okay. Now, so அதனால இது -3 இருக்கிறதுனால இங்க 3யும் +1 இருக்கிறதுனால இங்க 1 வச்சுக்கோம். முடிஞ்சதா? ஃபர்ஸ்ட் என்ன சொல்லிருக்கோம்? we have to balance other than hydrogen oxygen. இப்ப இதுல பாருங்க phosphorus hydrogen oxygen இருக்கு. phosphorus balance ஆயிடுச்சு. Now we have to go for the oxygen. So to balance oxygen atoms. So we have to multiply. இப்ப பாருங்க இங்க 3 2s are 6. இங்க வந்துட்டு ஒரே ஒரு ஆக்சிஜன். அப்ப என்ன பண்ணலாம்? We have to multiply by 6. எது OH. So P4 plus 6 OH minus, it gives PH3 plus 3 H2 PO2 minus. இப்போ oxygen also balance. But the hydrogen atom 6, 3 2s are 6 plus 3, 9 hydrogen atom இருக்கு. Hydrogen atom balance ஆகல. So we have to balance the hydrogen atoms. So என்ன பண்ணலாம்? இங்க பாருங்க, what is the rule said? Acid medium, add H2O to balance oxygen hydrogen, to balance the hydrogen. In acid medium, add the water to balance oxygen and hydrogen. Okay. In basic medium, add OH to balance the charge, add water to balance hydrogen oxygen on the other side. இப்ப இங்க பாருங்க, எந்த சைடு ஹைட்ரஜன் அதிகமா இருக்கு? இந்த சைடு ஹைட்ரஜன் அதிகமா இருக்கு, 9 இருக்கு. அப்ப ஹைட்ரஜன் ஆட் பண்ணா என்ன பண்ணும்? We have to add the water on the reactant side. So எத்தனை ஹைட்ரஜன் இருக்கு டோட்டலா நமக்கு வேணும்? 3 ஹைட்ரஜன் வேணும். ஸோ ஹோல் நம்பர்லாம் போட முடியாது. 3 ஹைட்ரஜன் சொன்னா அதுக்கு இன்னொரு ஃபோல்டர் போடுறோம். அப்ப என்ன ஆகும்? P4 plus 6 OH minus, then we are adding water. It gives PH3 plus 3H2 PO2 minus. So 3 2s are 6, 6 plus 3 9. So here 6 plus 2 8. So it's not balanced. So we have to, when you are adding water on one side, add OH to balance the charge. Okay. அப்ப என்ன பண்றோம்? We are adding 2 more. 6 plus 6 12. So 3 plus 6 9. Then remaining become 3 OH minus. Now you put it, the overall reaction, P4 solid plus, இப்ப டோட்டலா பாருங்க, இங்க 6 OH minus இருக்கு, இங்க 3 OH minus இருக்கு. இதுல இருந்து இதை ரெடியூஸ் பண்ணலாம். Then 3 OH minus, then 3 H2O liquid, it gives PH3 gas plus 3 H2 PO2 minus aqueous plus, அவ்வளவுதான். இப்ப பாருங்க, கரெக்டா பேலன்ஸ் ஆயிடுச்சு பாருங்க. ஃபைனலி we reduced it. அவ்வளவுதான். இங்க ஆட் பண்ணி இதுல ரெடியூஸ். That's it. கடைசியா ஹைட்ரஜன் ஆக்சிஜன். இப்ப நம்ம அயன் எலக்ட்ரான் மெத்தட் போடலாமா? ஃபர்ஸ்ட் எது ஆக்சிடேஷன் ஆகுது, எது ரெடியூஷன் ஆகுது? முன்னாடி பார்த்தோம் இல்லையா, என்னது? P4 it gives H2 PO2 minus. So இதுல 0ல இருந்தது, it become +1 ஆச்சு. அப்ப இது என்னது? இது ஆக்சிடேஷன். ஏன்? Loss of electron oxidation. And then P4 it gives PH3. So this is called reduction. Yeah, the 0 become -3. So the gain of electron reduction, loss of electron oxidation, gain of electron reduction. Now first நம்ம என்ன பண்ணோம்? oxidation எடுத்துக்கலாம். So oxidation of reaction. P4 it gives H2 PO2 minus. So first balance பண்ணோம், phosphorus balance பண்ணோம். Here we have 4 phosphorus. Here we have only one phosphorus. Up and up now, you have to multiply by the 4. So the P4 gives 4H2 PO2 minus. இப்போ hydrogen முதல்ல phosphorus balance ஆயிடுச்சு. Now we have to balance the hydrogen. So hydrogen balance பண்ண என்ன பண்ணணும்? Hydrogen oxygen. We have to add the hydroxide. அதானே சொல்லியிருக்கோம். இங்க பாருங்க. Balance the hydrogen and oxygen. Basic medium, each excess of oxygen add water to the same side. 2 OH minus ion to the other side. So 1 OH minus ion for each excess of hydrogen and adds to the same side. 1 water molecule on the other side. So இப்போ என்ன பண்ணணும்? ஹைட்ராக்சில் அயனை சேர்க்கணும். அப்பதான் வந்து ஹைட்ரஜனையும் ஆக்சிஜனையும் கம்பேர் பண்ணுவேன். 4 2s are 8. 4 2s are 8. So டோட்டலா 8 இருக்கு. அப்ப என்ன பண்ணலாம்? 8 P4 plus 8 OH minus, it gives 4 H2. H2 PO2 minus plus 4 electrons. We have to balance the charge, no? இது ஒரு equation. And then reduction of reaction. P4 gives PH3, 0 to -3. So first balance பண்ணா phosphorus balance பண்ணா P4 gives 4PH3. Okay, இப்போ phosphorus balance ஆயிடுச்சு. But we have to balance the hydrogen atom by adding OH minus and water. So என்ன பண்ணலாம்? P4 plus water, it gives 4PH3 plus OH minus. Look here, how many hydrogen is there? 4 3s are 12. 12 hydrogen is there. So how many hydrogen water molecule you have to add? You have to add 12 water molecule. 12 into அப்பதான் வந்து oxygen become 12 இல்லையா? So 12 2s are 24. So 24 ல 12 போயிடுதுன்னா மீதி 12 இருக்கும். So 12 OH minus. Now that it will be balanced. So when you are adding water, that much electron will be added. So now in the equation, we have to take both the equation and we have to cancel out. So to cancel out electron gained or lost by multiplying equation 1 by 3, because 4 electron, here 12 electron. So when you are multiplying 3 times of this and then cancelling the equation common terms, we will have the first இதை multiply பண்ணோம். Multiply பண்ணா 3P4 8 OH, so 8 3s are 24 OH minus gives 12 H2 PO2 minus plus 12 electrons. Then this reaction P4 plus 12 H2O plus 12 electron, it gives 4 PH3 plus 12 OH minus. When you are cancel outing, subtract பண்றீங்க 3P4 னா எத்தனை P4 வரும்? Twelve electron cancel. 2P4 இதுல 24 OH minus இருக்கு, இங்க 12 OH minus. அப்போ 12 OH minus plus 12 H2O gives 12 H2 PO2 minus and 4 PH3. So we can divide by 2. Then P4 becomes 6 OH minus. Then it becomes 6 H2O. Then it becomes 2pH3 sorry, totally 4p4, 3 plus 1 4, no, 12 OH minus 12 common opposite side la irukadha correct idhula correct illa, so we have to multiply divide by 4, then it become p4 plus 3 OH minus plus 3H2O, it gives 3H2 PO2 minus and pH3. So this equation and this equation becomes same. P4 3OH minus 3H2O. This is how you have to arrive the redox reaction. Okay, clear? Yeah. Is it clear? Clear, ma? Okay,
Yes,
we
sir.
will wind up the class. Yes. Doubt na kekla illa we can wind up the class. We will meet on the Saturday. If you have doubt, you can ask. Otherwise, we will meet in the other class.
Okay, sir.
Okay, sir.
Okay, ma.
Thank you, sir.
Okay.